Experiments in their chemistry lab knows this is produced through the emission of vapor state species in the flame. And let me break into the advanced chemistry for just a moment. This is what happens when free electrons and all this heat and flame and plasma are bumped up to their next energy level. They'll sit up there with all that extra energy, but very quickly do they so-called relax back down to their original electron orbital. And all that extra energy that they took on has to go somewhere. And if we can tune it right, if we use the right materials, that energy that it lets off in the form of a photon, a packet of energy, happens to be at just the right wavelength that the human eye perceives it as a color. If it's at the right wavelength, we'll see it as red, we'll see it as yellow. Well, it just so happens that strontium, if we put it into the right compounds and get it to burn just correctly, will burn red. Calcium will give off an orange color. Copper will give off very deep blues, which is my favorite. Barium or boron compounds will give off green. Yellow you can see with sodium atoms. In this case, you're not looking at molecules, but you're looking at that very strong sodium D line. It's so strong, in fact, that if you're trying to make any other color, like green or red or orange, you have to make sure you have no sodium at all in that composition. You can't use sodium nitrate. You have to use potassium nitrate. Otherwise, the sodium will wash everything out. Interestingly, you can also mix your orange and your green to make yellow. Not something you would normally think of if you were mixing paint, but in this case, these are emissive colors and not absorption colors. So orange and green in this case makes yellow. Violet colors, of course, you can mix red and blue compounds to make purple colors, and all of the many chartreuses and mauves and aquas and aquamarines and many different rose and peach colors in between.